Hi guys, my name is Aya Anwar, and today we are going to be talking about the role of oxytocin in milk letdown. So this video will focus on a learning objective from class 2021. It's going to be learning objective number 4. This is from the reproductive unit in the pregnancy and labor lecture, and it was presented by Dr. Olson in our previous unit. The learning objective asks us to explain the role of oxytocin in milk letdown. Alright, let's get started. So first we should review where oxytocin is released from. Oxytocin is released from the posterior pituitary. As we know, the posterior pituitary is an extension of the hypothalamus. Unlike the anterior pituitary, the posterior pituitary does not synthesize its own hormones. These hormones come from the neurosecretory cells in the hypothalamus. These cells produce oxytocin, which acts on the mammary glands, which we will be focusing on for this learning objective, and it also acts on the uterus. In addition, the neurosecretory cells also produce ADH, but we will not be focusing on that for this video. So on the right-hand side of the slide, we have a picture from our textbook, and as we can see, oxytocin is released from the posterior pituitary, and it is now released into the bloodstream where it can act on the mammary glands. As we said, we'll be focusing on this for this learning objective. Okay, so what is the role of oxytocin in milk letdown? As we said before, oxytocin is a hormone released in the bloodstream. This activates receptors in the breast, which stimulates the contraction of the myoepithelial cells. Finally, this causes milk to be ejected from the breast. So this is a really brief overview. On the next slide, we'll be diving into the milk letdown arc. Alrighty. So attached is a picture from Dr. Olson's lecture that you can follow along with if you're more of a visual learner or if you just kind of want to see what's happening. So first we need a stimulus. Our stimulus is going to be the baby nursing at the mother's breast. This activates mechanoreceptors in the breast. As Dr. Olson stressed, we need a receptor to be able to sense that stimulus so that the mother knows that a baby is nursing at her breast. So once these mechanoreceptors are activated, an afferent nerve can then go to the hypothalamus, which activates the posterior pituitary, and now we have oxytocin release. From the bloodstream, oxytocin activates the myoepithelial cells. This activation causes the myoepithelial cells to contract and milk to be ejected. So this feedback loop will continue until the baby stops nursing. So if we think about this, this is an example of a positive feedback loop. And then I just wanted to quickly talk about what happens when a nursing mother hears a baby cry. So this pathway is initiated by the activation of the afferent nerve. So if we think about this, we're skipping the first two steps, the stimulus, the baby nursing at the mother's breast, and the mechanoreceptors being activated. This is okay because nursing mothers have auditory sensory nerves that depolarize when they hear a baby cry. This eventually leads to milk release, even when there is no baby to nurse. So the same milk letdown arc that we were talking about in the previous slide occurs, we just don't have the first two steps. And yeah, that's all I have for you guys. Thank you for listening, and good luck on the final.